Yeah, hi everyone. In this video, I'm going to discuss about unordered map, and then I will be going to compare this unordered map with the map with respect to their time complexity and observation and how we have to pick unordered map or map. Okay, so let's start. First, what this unordered map and map it is. First of all, let's uh, how we are going to declare. Okay, first for the declaration. For this thing, we have a standard keyword called unordered. Okay, the way how it was map in the map, same way here it is unordered underscore map. So let me write it. That's unordered underscore. This is the way we have to represent it. Okay, now this is also associative with the key and value pair. Okay, the same way it's a sequence of key and value like how it was in the map. Little difference is there in unordered map which will help you a lot. Okay, so first of all, I have to pass two data type, sorry, yeah, two things, key and then value. Their data type having no any such restrictions. The same way how we have discussed in pair map, the same way here in another map there is no restriction on their key and value. Whatever you want, you can declare and you can utilize those. Even it is not only the defined data type, you can utilize it with your own data type. Means user defined data type, either you are going to utilize it as a structure or it is you are going to utilize it as a class. That's your choice. Okay, so let's further, I'm going to, for now I'm going to take it as intent. Okay, let me take it as ump. So first this declaration is done. Now the thing is, it is something which is used to store the key and value. For a particular key you might be having some value, right? So there might be some little difference. I will write the code and you just tell me in the comment section that what difference you observe here. Okay, so let's check it. First we will be inserting some elements. So here how we are going to insert, they're asking for a pair. Okay, this is nothing but they're asking for a pair. Okay, so how we can pass the pair, all other way like how I have explained in the pair video. If you want, you can create the pair. This is nothing but pair, right? Let me create the pair. Okay, suppose this one is pair. Now I'm going to insert the value for the pair. So here we have this declaration also, p dot first equals to suppose 4. Now p dot second equals to 7, right? Now this p is a pair, we can insert it. That is done, that is done. But this is not a good way. Or what we can do, we can directly initialize here also, but let me run this first. Okay, so first of all we want to print, right? So I will be using auto keyword where I'm going to take the element from another map and let's print it. There's something wrong, that's not recommending. Okay, fine, let's print the output first. We have being key and value, so how we can extract those? So we are having two iterator, if I'm not wrong, that we have discussed in the pair video. Same thing we are utilizing. The pair video is one of the important part for this map and another map. If you haven't seen those things, then please I will recommend you to go there and watch it and come back again here. I will be uh, going to pin that video in the I section. You can check there. Okay, okay, leave it. Then we are going to print. Okay, we are getting it. If I'm not wrong, whatever we are expecting, that we are getting first and second. This is the key. 4 is key, and then 7 is the value. Okay, this is the long way to write the code. I will be suggesting you in a smaller way, easy way. Okay, let me comment this and pass the value here only as a key and value. That's it. That should work. That is working. But instead, do you think, is it not a big thing? Just we are writing pair and we are declaring, then we are passing. Can we do? I have explained you that we can pass it directly. Let's comment this and pass the same value as a key and value. If somewhere you're finding key and value, just you pass it into the curly braces with two value first key comma value. Okay, that will work much better. That's fine. Okay, now we are cool. Next, next what I am thinking, like why we are using this another map. We have another thing. So for that observation, I will be putting some more elements and you observe. Let's check it. I have this 14. Let me copy some more data and run this and check the difference. You are getting okay. First 98, 12, 9, 98, 12, then 4. Okay, 98, 12, 4, 14. Let's check for another time. 98, 12, 4, 14. Any observation you are facing? 98, then 12, then 4, then 14, 24, 9. Is there anything? Matching nothing. So this unordered map is telling we don't follow any such orders for the key, the way how we were doing in the map. That's why it will consume less time with respect to the map for associating a data for the next time. Like if you're inserting one more data at that time, this is going to be faster with respect to the map. But you would have to come into a situation where you are going to utilize, is it really the way we are using unordered map? Why? See, if sometime you need a key, you need all the key, but that should be in a particular fashion, that should be in a particular order, then you cannot utilize unordered map. You have to go for the map only, right? So that thing you have to take care when you're utilizing unordered map and when you're utilizing the map. So everything, every functions, everything are same, just the thing is different. Like in another map they are not going to set this key as a sorted order the way how it was doing in the map. Okay, so now the time complexity where it is coming into picture. So for this thing I will tell you this map is internally, or I can say technically, whatever you feel better, that internally they are implementing it with the balance tree. Okay, balancing tree they are utilizing, and there is a specific balancing tree. It's so called red black tree. Okay, it's utilizing the red black tree in itself. It's a very important and hot topic, but it is not that much useful, I believe, for now. Means it's wrong, but it's very useful, but for now it's not that easy that we can discuss in this video. We'll do it further in the in some of the next video. So right now we having this map. So this is gonna to set the or going to insert the value or element each time, and it will consume big O of login. Okay, it is going to consume the big O of login. So suppose if I am trying to put the n elements, then it will end up with the big O of n login if I'm not wrong. But see, the case for unordered map, let's referring with UMP. Let's go for the next. Okay, in unordered map, I have this big O of one time complexity for putting one element. Okay, the way how it was big of login for inserting an element in what can I say, map. Okay, what here I can say it is taking only big of n for inserting the data into an order map. Fine. So for n data it is going to consume n into big O of 1, that is nothing but big O of n time complexity. So at that time you have to come into situation where you are utilizing that, okay, what data structure exactly I need. If it is not needed any sort of structure, any sort of sorting for the key, then you should not to go for the map because it is going to take more time with respect to the unordered map. If you are able to solve with the unordered map, that is fine. Okay, I believe I have done with the declaration and observation. I have given an example, but I will be just taking one more example. Let's say I'm telling just you count the number of element for each and every key. Means you are given a number, you have to tell me the occurrence, how many number of time an element is coming, right? So suppose I have having an array of 1 2 1 3 1 2 4 5 6 and like that. Okay, and I'm telling, just tell me the occurrence of each and every element. At that time there's no need to worry, you can utilize the unordered map, because I'm not asking for any sort of particular fashion like you have to print the count of each and every element, but that should be in the sorted order. First you have to print for the smaller number, then you have to go for the bigger one. I'm not telling that. That's why you can utilize the unordered map. In the same way you can just try from your own. I will be covering some few more questions. I will cover this topic as well, means this question in the next video. So this is done for observation, unordered map versus map, when you have to utilize this. Okay, let's do this question. Let me take as a vector int of v. I have this element, fine. Now I will be iterating v, and I'm telling that let me take another map. I will comment this. I will comment this all, and let me take this unordered map. So I have this unordered map of EL, and let me do plus plus. So initially for each key it is 0. Now it will be incrementing by 1. Let me print the output. That's it. Okay. I can say element of unordered map. So I can say C out element dot first, element dot second. For each and every element I have the answer. Let's check it. What I am getting: 6 5 1 2 3 4. Okay, 1 2 3 4 5 6. This 1 2 3 4 5 6. Okay, this element we have unique: 1 2, then 3, then 4, then 5, then 6. This unique element are we having. But for 6 we have to count, for 5 we have to count, but for 4 we have to count, 3 we have to count, 2 and 1 we have one count. So that we have got into the output. I hope so you are able to get this. And let's say what will be the time complexity for this. This is the time complexity that's linear. Okay, big of in whatever it is. Thanks for watching the video. If you really love this content, then don't forget to hit like, share, and subscribe button. It motivates me for making such new content. I hope you will do this. Once again, thank you very much for watching this video, and we will be meeting in the next video.